Hello learners, I'm called Festus Shundwekesa, a teacher of mathematics and physics. Today I'm going to take through this topic known as heating effect of electric current in physics, and the subtopic or the lesson of today is energy changes and potential difference. The main objective of this lesson is by the end of this lesson, you as a learner, you are supposed to define heat and electric current. That is 1. 2, be able to explain these energy changes and potential difference. And 3, explain 3 factors determining heat produced by this electric current. Welcome to this lesson. Now, I'm going to explain the key terms in this topic known as heat and electric current. Heat, for you as learners, heat is a form of energy that moves or that is transferred from a body at a higher temperature to a body at a lower temperature until an equilibrium is reached. This area, we covered it in Form 1. Then electric current, we also defined it in Form 1, and we said that this current, it is just a flow of electric charges in a complete circuit. Then after that, the subtopic of today is energy changes and potential difference. Now, this heat, it can be produced from different components. For example, I may have a phone. When I use it for a certain period of time, you may realize that it is getting hot. And I've said, or it is getting warmer. And I've said from the definition, it is a form of energy. So when you touch that gadget or that component, you realize that it is hot. So that is a form of energy. Even a dynamo on a bicycle, you may see that this energy is being transformed to light. When a dynamo is connected or it is on a motorbike, or we have a bicycle, you realize that energy is being transformed. So current is being transferred from one form to another. Charges are flowing from one point to another. That is the current. So when you connect a circuit, you realize that we have some components that they may become warm when you are using them. For instance, I know that if you have come across something like iron box, when you are ironing clothes, you realize that it may reach a time that the iron box is warm. So in that state, we always say that current is being transferred from one point to another. Then that iron box being warm, so it simply means that we have some form of energy, that is heat, that is being produced. Now, for today's lesson, the current, when it is flowing, it produces some heating effect on a coil. And that current, when it increases, then the amount of heat that's being produced, it also increases. So, learners have said that I've defined the term heat, and this heat I've said that it is just a form of energy that transfers, that is form of energy that moves from a body at a higher temperature to a body at a lower temperature. So it reaches a state whereby when you are feeling that form of energy, it reaches a state whereby you cannot detect whether it is cold or warm. For instance, during morning time, you may find that a chair is too cold, but after some times, you realize that the chair, it is warm. So that state where the chair, it has attained some equilibrium, whether you cannot determine whether it is hot or warm, that state we normally call it thermal equilibrium. It is equal. It is not cold and it is not that warm. Then after that, I've defined the term current. And I've said that current, this one, it is just the flow of charges. Current. This one is the flow of charges from one point to another in a complete circuit. And a circuit, it is just a connection of connecting wires that allows these charges to flow. Sorry for that. So this electric current produces heating effect. I've used an example of electric iron box. I've used an example of electric kettle. I've used an example of this dynamo on a bicycle. So during that time, you realize that it is warm. So meaning that that electric current, when it is flowing, it produces some heating effects. So I have said this electric current, the electric current produces some heating effect. Produces heating effects in coils. These coils, it is just a connection of wires in number of turns. So connecting wires. So when we have that connection of wires, so then when current is flowing through it, so it has that heating effect in that coil. So a higher current produces more heat. When we allow more current to flow, then it simply means that more heat is being generated. So we can as well say that a higher current, that is a higher current, produces more heat. So heat and current is directly proportional to each other. When I increase current flowing through that circuit, then it simply means that heat that is being produced, it is also increasing. Now, we have this issue of electromotive force. So what normally causes this heat? What normally causes this heat in these components? It is because of the resistance between the direction that is being moved by the current and the direction of charges. Remember in Form 1, we said that charges and electric current, they always move in opposite direction. So that resistance is the one that normally causes the heating effect in that component. So if you may be asked in exam, what normally generates this heat in a component when current is flowing? So it is very simple. You just say that it's just because of the resistance between the direction that is being moved by the charges and current. So that is the cause of this heating effect. So we can say the electromotive force, the electromotive force of the battery forces a flow of electron around. It forces around the circuit against resistance. Around the circuit against the resistance offered by various components. Offered by various components. So the resistance is the one that normally makes that component to be warm or to be hot. So that resistance between the flow of current and the flow of charges is the one that leads to the production of that heat. So if the amount of heat produced is increased, then the coil may get red hot. If that amount of current heat produced is increased, then it simply means that that component it becomes red hot. So you can say if the amount of heat is if the amount of heat produced is increased, if the amount of heat produced is increased, the coil may get red hot. The coil may get red hot. The coil may get red hot. And remember, I've said this heat, the only way we can increase it is by increasing the current. The current, a higher current produces more heat. So when we increase this heat, meaning that current has been increased, so the coil may get that more hot or get red hot. Then further heating, you may realize that we may get another component, for example, a bulb in a torch. After allowing more heat to flow through it, you realize that it gets burned. So when we allow this more heat to flow through the metal, it causes some break from the crystal lattice, making the wire to melt. So when that wire melts, so it does not allow that flow of current. So I may say that further heating will cause metals to break. So when we continue heating, so further heating may cause the metal to break. So it may cause the metal to break free. So if it breaks free from the crystal lattice, so when it has broken, so by making what? The wire to melt. So from the crystal lattice, making the wire to melt. So when that wire has melted, so it simply means that it does not allow the flow of this current. So that component, it does not function. And I know most of the time, you may realize that you have even a charger that you are supposed to use to charge that phone. But when you are connecting, that current is not flowing through it. That simply means that a component inside that charger, it melted because of excessive production of heat. So that is how this heat is produced. So the next part of this topic as a lesson, as I had mentioned in the objective, is to explain these three factors that determines heat produced by electric current. So we have factors determining heat produced by electric current. Factors determining the heat produced by electric current. So here we have three factors that normally determines the flow of this, that normally determines heat produced by this electric current. Most of the times, when you overcharge, when you charge a device, when you allow more current to flow through that device for a longer period of time, you will realize that that device or that component, it gets hot or more hot. Now, meaning that the first factor in this area, it is time. When you overcharge for a longer period of time, so it gets more hot. So meaning that time and electric current or heat produced is directly proportional to each other. So we have the first one is time. The first one is time. Time, this is just a topic in physics in Form 1, and we defined time. We said time, this one is just a measure of duration of an event. So measure of a duration of an event. For example, a lesson, it may take 20 minutes. That is an event. That is the duration. So time. So time, when we hit a component, when we allow currents to flow through that component for a longer period of time, that simply means that more heat is being generated. So that simply means that this time heat produced is directly proportional to what? To the heat. Time and heat produced is directly proportional to each other. So we can say that heat produced by an electric current device, heat produced by an electric current, is directly proportional to the time taken. So heat produced by an electric current is directly proportional to each other. That simply means that directly proportional, it simply means that when time increases, then heat produced also increases. I can illustrate it using a graph. For example, if I may have a graph here, as showing the relationship between time and heat. So we may have here heat, then we have here time. Time being measured in seconds, then heat in joules. So meaning that if time increases, the heat produced also increases. So we always have a straight line passing through the origin. This shows the relationship between heat produced and time. So the graph here illustrates or shows how increase in time increases what? It shows the corresponding increase in that heat produced. This is the first factor, time. And the second factor is resistance. The second one is resistance. Resistance of a component. Resistance of a component. So resistance, we may talk about the resilience of that object to sustain some heat, or the length of that object. So when the length of object is long, so meaning that it requires a lot of heat to make that object gain some heat. So similarly, resilience, because in Form 2 work, we talked about this things of resistance and current and voltage from Ohm's law, and you realize that resistance, we have devices with different resistance. We may have a device of 10 ohms, we have 20 ohms, we have 100 ohms, we have even 1000 ohms. So this one simply means that that component or a device with 100 ohms is there to sustain a lot of current that normally flows through it. So here similarly, I can say that even here, heat produced by an electric current is directly proportional to the resistance of that component. So here we can also say that heat produced is directly proportional to the resistance or length. We can put this one into bracket. So resistance or length of the component. Resistance. So heat is directly proportional to that one, to heat, to that length or the resistance of that object. So when the resistance is high, so more heat is also produced. Similarly, we can illustrate it using even the graph. That shows that it will also produce a straight line passing through the origin to illustrate that increase in resistance also increases heat transfer. Then the last factor here, number 3, we have the current. And current, as I've said from the introductory part, I've said that if more current is allowed to flow through the device, so it produces more heat, meaning that it is also one of the factors that affects or that determines the heat produced by by electric current learners. Now here, from this, the introductory part, it simply shows that this current flowing through an electric device or component is also directly proportional to the heat produced. So I can say again, heat produced here, heat produced is also directly proportional to the electric current. Directly proportional, directly proportional, directly proportional. Directly proportional simply means that increase in one quantity results in the increase in the other quantity or variable. So when I increase current, then it simply means that I have also increased the heat that is being produced. Then after that, I can summarize these 3 factors using one relationship. I can summarize the 3 using the 3 relationship. So summary, because now the common figure here is heat, 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 and the 3 parameters, they are variable, they are varying. So I can say that this heat, then sign of proportionality is equals to I squared. Then we have RT. Experiment, it has shown that here, this one, it is heat is directed to the, here, it is directly proportional to the square of current. Square of current, not just current, but square of current. So current, we must square it, but the other variables, they remain the way they are. So generally, we can summarize that equation using this one. And when I remove this sign of proportionality, so I have my equation as H equals to I squared, then RT. This one, it is known as Joule's law. Joule's law of electrical heating. It is a law. So Joule's law of electric heating, it is stated as this one, H, heat. This stands for heat. Then I stands for current. Then you have R stands for resistance. Then T stands for time. So I can say this H, this one is equals to heat, or it is heat. Then I is equals to current. Then we have R, resistance. Then we have T, stands for time. But we may find that we have other books. This Joule's law, they may replace H with E. This E, we may have this H, or we may have E. This represents what? Energy. So other books, they may state this relationship between the three components as E equals to I squared RT. So it is just the same thing. H and E, they simply mean the same thing. Now, if somebody may ask you to state Joule's law of electrical heating, Joule's law of electrical heating, we just derived the law from the three factors that determines heat produced by this electrical current. So we may say that this Joule's law of electrical heating, Joule's law of electrical heating states that the energy developed. So it is going to be energy or heat, because we are talking about heat, and I've said here heat and energy, it is just the same thing. So this heat or energy developed in a wire is directly proportional to 1. Now I've said we are just summarizing the three factors. Is directly proportional to the square of current, time taken, square of current, we can denote it as I squared, then time taken, that is T, and the resistance R of the wire, and the resistance R of the wire. Now this is Joule's law of electrical heating, which states that the energy developed in a wire, but this wire previously I've used a coil, and a coil or wire, because I had said a coil is made up of wire, is directly proportional to the square of the current I square, time taken, this one we can use T capital, and the resistance R of the wire. That is the Joule's law of electrical heating. Now, this marks the end of the lesson of today, whereby our main objective was to define heat, then electrical current, then also to show how this electromotive force moves in terms of energy changes and potential difference. Then we also explaining factors determining heat produced by electric current, whereby I've explained we have 3 of them. Time, I've explained that one as heat produced direct proportional to the time taken. we have resistance, then we have current. And I've said these three factors, they are summarized using this Joule's law of electrical energy, which states that this one I've stated, it is there. I've explained the letters that it represents. We have H, I, R, and T, then E. But remember, learners, this space in mathematics or in physics, it simply means it's multiplication sign. You can as well put there multiplication, or if you leave, there is no problem. Now, for the assignment of today, you can as well write down and try these questions at home. So the first one, kindly define the following terms. One, we have heat. Then two, we have current. Then you can as well define this one, temperature, because this temperature I've mentioned it somewhere here, but remember we covered in Form 1 temperature. Then the second question, explain three factors determining heat produced by electric current. So this is the assignment that I would like you to try when you are at home, and when we meet next time, we shall apply this formula relating current, resistance, and time. Thank you.